All right, today we are starting our last new chapter of Algebra 2. This is it? This is our last chapter, chapter 9. Well, I think we do another, like a small trig unit at the end if we have time. But this is our last, book chapter that we're doing. All right, today we are going to use inverse and combined variation. So, before we get too far into that, the first part is more of like a reminder from back in chapter 2. Back in chapter 2, we learned about direct variation, which is of the form y equals kx. Anyone remember those problems? Okay, so they're bringing that back today, but we're going to add a little bit more to it. Remember that k is the non-zero constant of variation. So most of the problems we had to figure out what k was. That'll be the same kind of thing today. Today we'll talk a lot about inverse variation, which is of the form y equals k divided by x. Or, if they solve it for k to be alone, x times y equals k. So that's how we can find k, is by multiplying x and y. Bless you. Now notice that here, for direct variation, k is being multiplied by x. And for inverse variation, k is being divided by x. Okay, so with direct, they get multiplied. For inverse, they get divided. In inverse variation, as x increases, y decreases, or vice versa. So when we learned about direct back in chapter 2, as one of them got bigger, the other got bigger. As one got smaller, the other got smaller. They went in the same direction. Direct variation, same direction. Inverse variation, they go in opposite directions. So if one gets big, the other gets small. All right, first example. Suppose that x and y vary inversely, and x equals 3 when y equals -5. Write the function that models the inverse variation. Now, off to the side, you might want to write yourself a couple little notes. This problem takes 2 steps to do it. So the first thing we have to do is find k. And then the second thing we have to do is what they actually ask us to do, which is write the function or write the equation. Okay, so these are our 2 tasks that we have to do. We need k in order to write the function. So finding k has to come first. In order to find k, there's 2 different ways you can do it. My favorite way, so that I only have to remember one equation for this, is just to write the equation in its general form, y equals k divided by x, because we are varying inversely. Plug in what they give me and solve for k. So what did they give me for y? -5. So -5 equals, careful, k over 3, because the 3 has to go in for the x. Now, how am I going to get k alone? Multiply by 3 on both sides. Yes, the second one is the same thing. However, in order to write our function, we have to use the y equals k over x. So that's why I said I like to only have to remember one equation instead of 2. But if you like to use that second one for this first part, that's fine, as long as then you know to use the other equation for the second part. I just like to use the same equation the whole time. Personal preference. Either way, we get the same k. What is it? Negative 15. So that is important. So if you want to put a little bubble around it, that's important. It's just not our final answer. What do we still have to do? Plug it in so that we can write the function. Now when we write the function, we have to use the one where y is alone. It's got to be y equals, but this time the only thing we plug in is k. My k is negative 15 over x. The only thing we plug in when we write the function is the k. And we've got to use this form when we're writing it, where the y is alone. Do we have questions about our first example? That's the answer. That's what they asked us to do. Write the function that models the inverse variation. That's it. All right, on number 2, what was our first step to being able to write a function? We had to do what? Find the k. So in order to find k, we've got 2 options. Who wants to tell me which way they found it? Which equation did you use? Okay, so we had 2 options. I like the y equals k over x. It's not the only one. So in order to find k, what are we plugging in for y? 3, and in for x, 1.2. In order to get k alone, we have to multiply the 1.2 on both sides. And what do we get for k? K equals 3.6. Now that's important, but it's not our final answer. What do we still have to do to write our final answer? Plug in k and only k back in that same equation that we used in the beginning. So y equals 3.6 over x. All right, this next set of examples is a little bit fun. So the directions at the top there are very small, but luckily they're written on your paper. We are going to use the tables to decide if the relationship is direct variation, inverse variation, or neither. It's possible that neither one of them work. And then write an equation, if we can, that models the variation. So we have to decide direct, inverse, or neither. In order to get started on that, to narrow it down a little bit, we have to just in general think about what is x doing and what is y doing. So if we look at A, what's happening with our x values? They are getting bigger. And when the x values are getting bigger, what are the y values doing? Also getting bigger. So if they're both getting bigger as we go, then what's our only possibility? Direct. So either it's going to be direct or it's going to be neither. Inverse is not an option. Does that make sense? So we narrowed it down. In order to know whether it really is direct or if it's neither, we have to see if we have a constant of variation, meaning that it's increasing at the same rate every time. So if it's going to be direct, we find k. Does anybody remember how we find k? K is found by taking y divided by x. Instead of multiplying them for direct, we divide the y and the x. And that would give us our variation, our constant of variation. So on this first one, if we take y divided by x, what would we get for k? 1.5 divided by 0.5. 3. Okay, if we take 6 divided by 2, what do we get? 3. If we take 18 divided by 6, what do we get? 3. So is this direct variation? Yes, because we got the same k every time. So if you even want to label this your k row, you can do that. Because k was the same every time, it's definitely going to be direct variation. And then we have to write an equation that models it. Well, luckily, we already figured out what k equals. So we just have to plug that back in to our general form, leaving y and x as y and x. So for direct variation, what's our form?
Y equals 3.
For direct, y equals kx is our general form. So when we plug our k in, it becomes y equals 3x. Okay, so it was direct variation. So therefore, the equation that models it is y equals 3x. Questions, concerns? Okay, on part B, remember we start off by narrowing it down by looking at how x behaves and how y behaves. So what's happening to our x values? They're going up, they're getting bigger. And while the x values are getting bigger, what's happening to the y values? They're going smaller. So what are our options? It could be neither, or it could be inverse. So inverse or neither. So we're going to check inverse. When we check inverse, we want to know what k equals. To find our k's, we take x times y. For inverse, we take x times y. Remember, that's the one up at the top some people were liking to use on those first couple examples. That's how we find k. So we need to make a little k row and decide what our k's would be. So we're taking x times y on these. So if I take 0.2 times 12, what do I get? 2.4. What about 0.6 times 4? And 1.2 times 2 is also 2.4. So is it actually inverse? Yes, because our k was the same every time. So yes, it is inverse. Now we have to write our final answer for an equation that models it. Remember, our general form is y equals k over x. So when we plug in just our k, we're left with y equals 2.4 over x. Questions, concerns? Okay, on the last one, part C, what's happening to our x's? They're increasing. What's happening to our y's? Decreasing. So what are our options? Neither or inverse. So could be inverse, so that one is what we'll check. We'll find our k values by doing what? X times y. So when we make our k column or k row, x times y. So 1 times 2, 2 times 1, 3 times 0.5. So is this inverse?
No.
Why not? They're not all the same k. So this one on the end was different, which means it's not inverse. That means it has to be neither or none. Okay, so our only options were inverse or neither. Inverse didn't work out. It has to be neither. So there is not an equation that we can write for it. All right, number 4 is a very typical type of problem that we saw when we were dealing with direct variation that seemed to just throw some people overboard a little bit here. So these ones have like 3 different parts to them. Anytime that we are told that we've got some sort of variation, which here they vary inversely, the first thing we want to find every time, anybody know what it is? Similar to on the front. Find K. If you know that you have some sort of variation, the first thing you should look for is K. The second thing you should do is write the equation. The last thing that you will do on these types of problems after you write the equation is to use your equation. That'll make more sense when we do it. But these are the 3 pieces that I want us to get used to doing on these. Find your K, write your equation, and then use it. So for finding K, we just use that first sentence that they tell us. X and Y vary inversely, and X is equal to 20 when Y is equal to 5. So if we're varying inversely, again, you choose which equation you like. I like to remember the same equation every time, so I like Y equals K over X. If you prefer the K equals equation for this first part, that's also fine. You can write it that way too. So we're finding K, we're going to plug in what we know. Y is 5 when X is 20. So either way you're working it, when you find K, it's going to equal 100. So this way we multiply by 20 on both sides. All right, now that we found K, we're going to write our equation. So Y equals 100 over X. That's all there is to it. We just plug in our K. Some problems just ask you to write an equation. That's fine. This one, we also have to use it. So it says, write a function that models the variation. That's what we did right here in the middle. So this is part of what they wanted. But then they also want to know what Y is when X is equal to 10. So that's when we're going to use the equation. Yes, we plug in 10. Y equals 100 over 10. So Y equals 10. Find your K, write your equation, use your equation. Hopefully, if we set it up this way every time, these problems will be less confusing this time around. Does this help? Having goals each way, each step of the way? Maybe for some people it will. Combined variation, as the name suggests, it combines direct and inverse variations in one problem. A specific type of variation is joint variation, in which more than one variable varies directly with another. So anytime you see joint variation, you need to think about direct variation for all variables. Combined variation, they'll tell you specifically if it's going to be direct, inverse, or jointly. For combined ones, it could be any mix of them, and we'll see that in the examples. Okay, we're going to focus on number 5, so I'm going to take 6 away for right now. Take it away. Let's focus on just number 5. Z varies directly with X and inversely with Y. So I would just kind of stop right there and write a very general function that models it. Now we know that at some point we're going to have to find k. We always have to find k. But I would start with that first sentence, just very general. If z varies, it's going to be z equals. You know you're going to have a k in there. So if it varies directly with x, is k going to get multiplied by or divided by x?
Divided.
For directly? Multiplied by. So remember y equals kx was direct. This time they just have z instead. So directly means k and x get multiplied. And inversely with y. That means that k and y have to be divided. So I'm going to put one big fraction bar and put the y on the bottom. So this is combined variation. It's doing it directly with x and inversely with y at the same time. Okay, now let's use all that information that they gave us so that we can find... What do we always want to find first? K. We got to find k. So what am I plugging in for z? 10 equals, I don't know k. What's going in for x? 5. And what's going in for y? 2. We got to get k by itself. So my first step is to multiply both sides by 2. 10 times 2 is 20. Equals k times 5. And then we have to divide by 5. So k equals 4. And then we still haven't actually written our function. So now we're going to go back to that very original setup we had, but now the only thing I'm plugging in is the 4 for k. So z equals, very good, 4x divided by y. That is the function that models the relationship. Questions, concerns? Ready for the next step? The next step should be easy. Once you have that equation from part A, now in part B, all we're doing is using that equation. So we're finding z. So z equals 4 times what's going in for x. 4 divided by what's going in for y. 8. 4 times 4? 16. Divided by 8?
2.
So z equals 2. Now we're done with number 5. Questions, concerns about 5 before we start 6? Are we sure? We all get it down? We're ready to move on? I'm a little afraid I'm going to have to erase some of it to get number 6 back. Is that okay? Okay. So we're just going to take it away so that we can bring back number 6. On number 6, I'm going to get it started with you, and then you're going to take over and wrap it up. So the only thing that I'm going to do with you initially is write that very general, generic function form. So it says z varies jointly with x and y. Now when we see varies jointly, what type of variation are we supposed to think about? Direct variation. And with direct variation, we have z equals, because z is the one that's varying, z varies, z equals, we know we need a k. Good. K times x times y. So they're all getting multiplied together when it's jointly. And that's all that there is for that very initial generic setup. We don't have to worry about it then being inversely by another variable like we did on number 5. So using that generic setup, I want you to finish off that problem. So write a function that models the relationship, which means you're going to need to find k, and then also answer part B using that function that you come up with. Let's talk about what we got on number 6. Can someone raise their hand and volunteer their function that they got for part A? Emily?
Wait, you mean like my z equals k times x times y?
Mm-hmm.
Like what I got?
Yep, so really, yep, what'd you get? Z equals?
1.75 times x times y. Wait, that was from...
1.75.
Well, I got 7 over 4. So
Okay. So I like 7 over 4 better.
I just did it with capital.
Gotcha. So if you put 1.75, that would be okay. That is technically the same thing. I like the fraction, the improper fraction. If you put 1.75, though, it's not wrong. It is the same thing. So z equals 7/4 times x times y. Questions, concerns? Anybody get that? Couple people? Who got z equals 7/4 xy for their function? Or if you put 1.75 instead of 7 over 4, it's the same thing. So with that in mind, if you got A correct, then hopefully you also got B correct. Can anyone tell me what they got for Z on part B? That one I did not get to be a fraction. I agree with those of you saying 56. Z equals 56. You want to go through it? Okay. For the first part, we had Z was equal to 7. So I plugged 7 equals K times X was 2 and Y was 2. So 7 equals 4K or K times 4. And we divided by 4. So that's how we got K equals 7/4. Then when we plug in our X and Y to find Z on part B, the 4's end up cross-canceling. 4 times 7/4, the 4's would cross-cancel. 7 times 8, we got 56. All right, so again, I'm going to help you get your initial part set up and then turn you loose for a few minutes to see if you can get the whole thing done. So Z varies directly with the cube of X and inversely with Y. So now we've got 2 different types of variation. Still, it's going to start off with a Z equals. Direct means that K and the cube of X are getting multiplied. With direct variation, K gets multiplied to that variable. So it gets a little confusing because then to find K, we would have to use division with direct. But in direct variation, the original formula, it's going to be K times the cube of X. How would I write the cube of X? X to the third power. And inversely with Y. So in inverse variation, K and Y would get divided. So this whole thing gets divided by Y. Do we have questions about that generic setup? Okay, once you have that, then you should be able to find K and then plug it back in for your model, your function that models the relationship. What did we get for our K value? 1. I got 1 earlier when I did it. So we would plug in 9 equals K times 3 cubed divided by 3. Multiply the 3 over 27 equals, cube the 3, we get 27 again. So that's how we got the K to equal 1. So when we write our function, Z equals, if you want to write the 1, you can, but you don't really have to. X cubed divided by y is fine. If you want the 1 in front of your x cubed, put it there. If not, don't worry about it. And what did we get for z on part B? 8. So when we plug in the x and y to this model that we found, we should end up with z equals 8. So we will pick up these notes tomorrow, and I'll get your homework posted on Classroom soon.